Hello guys, this is Code and Code and this is 7th lecture of string algorithm series. This is part 2 of KMP string matching algorithm. So let's get started. So prerequisite for this lecture is obviously 6th lecture of string theory algorithm series uh, because I'm going this is basically continuation of the previous lecture, which was lecture 6. So make sure you already watched 6th lecture before continuing to this lecture. Now, so this is where we left in the previous lecture. So to calculate pi of I, we have already proven that in the previous lecture we have already proven that pi of I can be at max pi of I minus 1 plus 1, right? This is the maximum it can be. And how we are going to check it? We'll be checking the ith character is equals to uh, pi of I minus 1th character or not. If this condition holds, then pi of I would be pi of I minus 1 plus 1. And we left at this question: what if pi of I minus 1th character is not equal to the ith character, which is basically this? What would happen if these two are not equal? This is where we left and this is where we are going to start again. So this condition you understand, right? To calculate pi of I, first thing we are going to see, we are going to do is that compare the ith character with pi of I minus 1th character, right? So if I show you the code I'm again using from cpalgorithm.com, link of which I'll be providing in the description of this video. So see here, I'm comparing for, first of all, this is a for loop that is responsible for calculating pi value for 1, 2 and minus 1, right? For each I from 1 to n minus 1. So what we are doing here is that you can see I'm comparing to calculate pi of I, I'm comparing s of I, just let me increase the font size, f of I with s of j. S is the string, s is the input string, so s of j. And what is j? J is pi of I minus 1. So what we are doing here is that I'm comparing ith character with pi of I minus 1th character, right? This we already know. If it is not equal, then what we are doing, we are updating j to pi of j minus 1 again, and then again comparing. So at least for the first loop, you know what is happening. We are comparing ith character with pi of I minus 1th character, right? This we already know. Let's continue to answer this question. Now to find the answer of this, let me just continue. But let me just show the code once again. So what is happening here, if the ith character is not equal to the jth character and j is initialized with pi of I minus 1, what we are doing, we are updating j again with pi of j minus 1, right? Not this time I minus 1, but with j minus 1 again, and comparing again till both the character either match or j becomes 0. So let me show you why we are updating the j. So see, when I'm calculating pi for this index, and before that pi of I minus 1 is 4, right? So pi of I can be at max 5. So it is either it would be AABAX suffix matches the prefix, or ABAX suffix matches the prefix. Basically the suffix of length 5 matches the prefix, or the suffix of length 4 or 3 or 2 or 1 matches the prefix, or nothing matches. So out of all of these we need to find the maximum one, right? Now to get for the length 5, to check whether the length 5 is valid or not, basically pi of I is 5 or not, we have already compared this, we have already tested this condition. If that condition fails, now I'm saying that j should be initialized with pi of j minus 1, right? J should be initialized with pi of j minus 1. Why is that so? Let me show you. See, when the length 5 doesn't match, either it would be ABAX. Now we have to see whether out of all of these something matches, because right, either pi of I would be 5 or 4 or 3, 2, 1, 0. Out of all of this we have to find the maximum. So now I have to check whether ABAX, which is suffix, matches the prefix or not. BAX, which is a suffix, matches the prefix or not. Similarly for AX, and then finally for X. But what we can't do, we can't directly go and compare them character by character. This would again lead us to the problem which will increase the overall running time, and that is what we don't want. So what I'll do, you see, can you find any relation between the AABA why I'm emphasizing on AABA, because pi of I minus 1 is 4. That means the prefix, basically the suffix AABA already matches with the prefix, right? You can see here AABA matches with the prefix AABA. So can you find any relation between AABA and the rest of these substring written in black color? ABA, BA and A. If you try to find a relation, you would see that ABA, BA and A, all of these three substring are actually suffixes of this AABA, right? These are all suffixes of AABA. And out of all of these, I want the maximum length suffix which actually matches the prefix, right? If so basically what I want is the longest proper suffix of AABA, which is also a prefix, right? That I want, because if I'm saying that okay, pi of I is 4, that means ABAX matches with prefix, right? If pi of I is 4 again, pi of this is 4, that means ABAX matches with prefix. If ABAX matches with prefix, that means ABA already matches with prefix, right? So that is why I want the maximum proper suffix of ABA, which is also a prefix. Now, don't you think that is the exact work of pi, right? What we are saving it in the pi array. Pi of I tells you the proper longest prefix or proper longest suffix of substring 0 to I, which is also a prefix, right? And that is exactly what we want here. We want proper suffix of AABA, which is also a prefix. And to find the answer of this, we can utilize the pi array. So if you go to the position pi of j minus 1, why pi of j minus 1? Because see, pi of j pi of j and j again was initialized with I minus 1. So pi of j was j was initialized with pi of I minus 1. So j is actually 4. Now j is 4. That means the first four character actually match the last 4 character, right? Because of course pi of I minus 1 is 4. So what you can do, you know that this suffix actually exists as the prefix. So if you find pi of this index, which is AABA, that will tell you exactly the length of the longest suffix AABA, which is also a prefix. So you see, pi of this index, basically pi of 3. Why 3? Because this AABA would add at index 3. That is why we are going for pi of 3. So if you see, pi of 3 tells you 1. That means for string AABA, only the first character is also the prefix. So see, only one character is also prefix. So see, in AABA, ABA would not match the prefix, BA would not match the prefix, only A would match the prefix. That is exactly what pi of 3 is telling you. And why 3? Of course, because j was 4, that means the substring length is of 4 size, right? And if the length of a string is 4, that means that substring ends at index 3. That is why we are going at index 3. So basically what we want is the longest proper suffix of ABA in this case, which is basically pi of I minus 1. Suffix, basically suffix of that length. So for pi of I minus 1, which is of length 4, so we are only considering AABAX because this was the longest suffix which matched the prefix. So for this, if this doesn't match, AABAX doesn't match, that means if pi of I is not equals to 5, it would be either 4, 3, 2, 1 or 0. We already know how to check for length 5, and that is using this condition. If the condition doesn't hold, that means what we want the maximum longest suffix of AABA, which is also a prefix. And answer to that exists at index in the pi array at index pi of j minus 1, right? J was 4, so at pi of 3, and that is exactly why we are updating j to be pi of j minus 1. And we will compare there again. So basically pi of j minus 1 is 1. So it tells that the longest suffix of AABA, which also is a prefix, is only A of length 1. This here it tells you. So basically only A matches. So this is the only candidate for us, AX. So we already know that A matches. All we have to do is check the second character. Second character lies at index 2. That is why we are comparing I with again J. And since J would become 1, so you are comparing character at index 1 with I, which is X. If this matches with X, so basically AX would match with AX, right? And that is exactly what we are doing here. So we will be updating J to be pi of J minus 1, and then again we'll run this loop. We'll again check the ith character with jth character. If this matches, we will simply stop. If this doesn't match, we'll again update J, and the same process happens till J becomes either 0 or the character match. If the character match, so basically what I'm telling you, J become 1, right? J has become 1. So if the first character at index 1 matches with X, so AX would match this, right? In that case, pi of I would be 2, right? 2, that means J plus 1. And that is why when we stop out of this, when we stop for this while loop, we check whether the ith character matches the jth character or not. If they match, we would simply increment J and update pi of I to be J. If they do not match, basically pi of J is 0. If they do not match, then pi of I would be updated with J, and J most certainly in that case will be 0. So this is how this whole algorithm works. This is only the calculation of prefix function. And same prefix function, if you understand the prefix function very well, then you won't be having any problem understanding substring search KMP algorithm. This is very, very, very easy once you are able to understand prefix function. So I hope this made things clear with you. If you have any doubt or query still remaining, you can post it down in the comment section. If I see that there are a lot of queries, so I maybe go for the one more lecture for KMP algorithm. Otherwise, we'll be taking on some problems related to KMP algorithm. So this was all for this lecture. Thank you guys for watching, and till the next video drops, keep coding. Thank you.